Hey there. So we're going to do one video on 2 days of homework. So you can decide to split that up however you like. This is my recommendation, is that you go through the first 2 questions and then you can work through this packet, or watch the entire video and then start on this section and then work as far as you can through 13 through 57 and attach these 2 presentation problems, having a full work day on Tuesday. Whichever way works best for you. It's completely up to you. Just make sure you get everything done by Thursday this week because you don't have school on Friday. So let's get started. Get yourself ready for notes. Now we're going to talk about finding real and complex zeros for polynomials. So we've talked about a couple of these different methods with quadratics and then with just finding real zeros. So one thing I want to start by doing is touching base about the fundamental theorem of algebra. Now, if you remember from previous lessons, the fundamental theorem of algebra says that if a polynomial has degree n, then it has n complex zeros, accounting for multiplicity. So remember, complex numbers are just all the numbers that you could possibly have. So if I'm looking here in number 1, I would expect 4 zeros, but some of them might have multiplicity. They might be repeated. So what that means is that if I have the equation x squared plus 2x plus 1, that has only one root, which would be -1, because its factored form is x plus 1 squared. So that one root has a multiplicity of 2, so 2 total, 1 times 2, which is equal to the degree. Now, I'm going to talk about a couple different strategies that we can go into when solving and finding roots of these equations. So, firstly is being able to factor a couple different types of polynomials. So here, you'll notice that we have a trinomial, which would hopefully make all of you think about factoring, which is exactly what you want to do. And we can because it's like a quadratic. And what that means is that I have 2x to some even power and b x to the n plus c. So in this case, we've got 4 and 2. If this was 16 and 8, we could still factor like a quadratic, meaning draw the line here, ask yourself what multiplies to that middle number, taking into account the leading coefficient. So if this was 10, 5, all of these would work as long as it follows this pattern. So in the case here, I will ask ourselves, okay, this is -1, 4, -2, 2, -4, 1. What adds to 3? Well, it's this first one here. And so when I write my factors, I've got -1 and plus 4. But instead of x in the front, it's x squared in the front. Because we have, that is our middle term, just like here. If this was 2x, we'd put x in the front of our factor over here. So here, the middle term, we put x squared in the front. Here, we have another factor. This is a difference of squares, so make sure that you're factoring everything completely, because x squared minus 1 is x minus 1 times x plus 1. And this is not a difference of squares, it's a sum, so we would leave its factored form like so. So this would be its complete factored form there. And its roots would be 1, -1, and then if I wanted to solve for the roots here, we would say x squared is plus 4 is equal to 0. X squared is equal to -4. So x is equal to plus or minus root -4, which we would also call plus or minus 2i. So there's your 4 roots, 1, -1, 2i, -2i. All right, hopefully this helps. We're going to talk about another type of problem, which is write a degree 4 polynomial with integer coefficients that have roots at -3, 0, and 2i. So the way I like to think about this is that we have the root, and then we have the factor. And since it's degree 4, we know we should have 1, 2, 3, 4 of these all the way down. Now, we're given 3 of them. We're given that we have a root at 3, which means the factor is x plus 3. We're given a root at 0, which means the factor is just x. And we're given a root at 2i, which means the factor is x minus 2i. Now, the important thing here is that we have an empty spot missing, so we need one more factor. And you're not just going to pick anyone, because we also have this integer coefficients, which means that we need to make it so that we get rid of this imaginary number through factoring. And if you remember what we need to do in order to have that, we need the conjugate. So multiplying by the conjugate here will mean that we cancel out the imaginary numbers. So conjugate, cancel the imaginary numbers, just like we saw in our previous lessons, leaving us with our fourth root of negative 2i. So in its factored form, that would be x plus 3 for our first factor, times x minus 2i, times x plus 2i. So this is its factored form. Standard form means that we have to do our multiplication. In this case, it's going to be foiling that I'm going to recommend. And what I find easier for these is just do them in like sets of 2 and then multiply them together, because the conjugates are going to simplify down pretty nicely and it'll just make the actual algebra a little bit easier. So then I end up with x squared plus 3x from the first two factors, and x squared minus 4i squared from the second. I squared turns this into just a positive, like so. And so now we're going to FOIL x squared plus 3x times x squared plus 4. So in standard form, we would get x to the 4th for first, plus 3x cubed is our inner, plus 4x squared outer, plus 12x for our last. And this would be the polynomial in standard form. If you want to pause now, you can. We're also going to do one last problem. Find all the zeros for y equals x to the 3rd minus x minus 6. This is going to be really similar to finding the real zeros, except for we might end up with imaginary. So if you remember from previous lessons, the first thing that we're going to do is list our possible rational roots and then see which ones equal to 0. So our rational roots will be plus or minus 1, 2, 3, and 6, because what we're looking at here are the factors of the term divided by the factors of the first term. And what we can do is I'm just going to start down my list and start plugging numbers in using my calculator, plugging them into the formula. So 1 plugged in would be 1 minus 6, so negative 6. This one is also negative 6. You can check my work on a calculator if you like. Here's negative, this one then is equal to 0. Okay, we found a root. Now, since it's a trinomial and it's got a third power, once I find one root, I know that once I divide that out, I'm going to get a quadratic, because divide a power out, we end up with something that we can put in the quadratic formula. So I'm going to jump right to my division. So if x plus 2 is the root, that means x minus 2 is a factor. And so just like we would in previous weeks, I'm going to divide that out. X cubed plus 0x squared. Remember, you can't skip a term in your countdown. You have to put in a 0. Minus x minus 6. And then I'll do my long division. X squared, x cubed minus 2x squared. Some of you definitely had problems with this just because of the subtraction. So I like to go in and change both signs just so that I know that I'm not as likely to make a mistake. Of course, that does not mean I'm not going to make a mistake. It's just a little less likely. So then 2x squared minus 4x. Then again, go and subtract this one. Change that sign when I do the subtraction. Get 3x minus 6, so plus 3. And notice that I ended up with a remainder of 0. If I don't end up with a remainder of 0 for something I know is a factor, I know I did something weird. So that's the nice thing there. And here's our quadratic. Now this is what we actually want to plug into our quadratic formula. So I'm going to separate things out a little bit. And our A is 1, B is 2, C is 3. So x is equal to negative 2 plus or minus the square root of 4 minus 4 times 3 all over 2. I skipped a little bit of arithmetic there. If you don't have the formula memorized, please again have it written out and you can check your work on the PDF. So this becomes negative 2 plus or minus root negative 8 over 2, which is equal to negative 2 plus or minus 2I root 2 over 2, leaving us with negative 1 plus or minus I root 2. So then all of our zeros and all of our roots are 2 from the beginning, and then negative 1 plus or minus I root 2. And we have all 3 zeros matching the degree. Let me know if you have any questions about anything that you see here. Remember, this is going to be the same video for 2 days, so feel free to jump around, rewatch as you need, and I'll be available on Zoom, email, or in the comments.